All right, 3M, I have to tell you, I'm frustrated. I did this video about a half an hour ago and then it crashed and disappeared. So I think I'm going to do this in 2 parts and hopefully it'll work for me. Anyway, we are doing factoring and we are going to use it today to find some information about real life problems and graphs. And so just as a quick review, when we need to factor something, the first thing we should always think about is if this expression has a common factor. After we've done that, we would look at the number of terms, and if there are only 2 terms, and specifically if there are 2 terms with a subtract, that may very well be a difference of squares. So a difference of squares looks like something squared subtract something else squared. If your expression has 3 terms, then we're looking either for a simple trinomial where there is no number in front of the x squared term, just a 1, or we're looking for a more difficult trinomial to factor, and we would have to use decomposition when you have a number in front of the x squared term that's more interesting than 1. We're going to look at this equation. We've seen a couple rather similar, but we're talking about a ball being thrown from a building and it falls to the ground, and its height is in meters and time is in t seconds, and here is our equation. We're going to look at the graphing calculator, and remember the graphing calculator can't do h's and t's, so we're going to type it in as y equals negative 5x squared plus 30x plus 35. And we're going to glean some key pieces of information. We're going to look for the maximum height and when the ball hits the ground, how far off the ground the ball was when it was thrown, and an appropriate domain and range. So let's have a look at the graphing calculator. All right, so you're going to get a chance to play with these a little later, but we're hoping that this will help us cheat a little bit and have a look at our function. So if I want to type in this equation, I am looking at the buttons across the top that are all my graphing functions. To type this in, I need to hit y equals, and I'm going to write negative 5x squared plus 30x plus 35. The negative is down at the bottom of the calculator, and it's fairly small, not a subtract. Negative 5x squared, and we'll play with this later, plus 30x plus 35. If I hit graph now, I may or may not be able to see it because I haven't given any thought to where this is situated on the calculator. So I can't see it very well. So I'm going to go to my Windows button. That changes the domain and range, and you know all about the domain and range. So in this equation, our x value, or t, represents the time. It doesn't make sense to have a negative time for a ball in the air, so we're going to change our domain to 0. And our largest value, well, 10 seconds makes sense to me, that a ball could be up for 10 seconds, so we'll leave that one. Let's change the range, which are the y numbers. My range doesn't make sense to have negative height either for a ball. That would be in under the ground. So I'm going to have my range go from 0 to what would be a good maximum height of our ball. Well, I see the number 35 in the equation, so I want at least 35. I think I'm going to go with 50. And then I'm going to hit graph again. I've given reasonable thought to my domain and range. And let's see how we do. Well, it's a lot better, but I still don't see the top of it, so I need a larger value for my range. So I need a number bigger than 50 so I can see the top of it. Let's go with 100. There we are. There is a good graph of our function. And it says, when is the maximum height of the ball and when does it occur? I can see the maximum height of the ball. It's right there. And I want the graphing calculator to give it to me exactly. So all of these buttons are for the graphing part of the calculator. So up above trace is the button calc. That does all the work for you. So I'm going to do second function trace. And there the choice that I'm looking for is maximum. They're kind of funny that you want to tell it where to find a maximum, and it's saying left. Well, I'm going to scroll along here until my cursor is to the left of the highest point. Okay, now it's definitely to the left. And it wants me to be to the right of that highest point. You're telling it where to look. Enter. And you can see the little arrows up above is saying the calculator is looking from there to there and finding the maximum value. Then it always wants you to guess, and that's just dumb. So hit enter. There you go. There is your maximum value, and it is at the point 3, 80. So I'm going to write that as a point, 380, and it tells us the maximum height is 80 meters. And that happens at 3 seconds into our story. Then it asks us when the ball hits the ground. You can see that, sort of. It's down here. It's an x-intercept, and where its height is 0. So I want to know an x-intercept for this particular question. So my graphing calculator will give me an x-intercept as well. And the choice that I'm looking for there is a 0. Number 2, x-intercepts and zeros are the same thing. So I want number 2. And you want to tell it to go to the left and to the right. So I'm looking for that x-intercept that's over here. So I'm going to go to the left of it, and I'm very to the left of it right now, but I'll get a little bit closer. Okay, I'm still to the left of it, and above it actually, but to the left of it, hit enter. You can see that's made a mark up above. Then I'm going to go to the right of it, and I'm just scrolling till I see my y value start to get negative. And then I'm going to hit enter. That's definitely to the right of my x-intercept. Enter again. 7, and that funky little thing is very close to 0. They just have some rounding errors. So my x-intercept right there is 70. The last time I did this, trying to record it for you, it did exactly 70. Silly thing. Okay, so that means it hits the ground at 7 seconds. Okay. How far off the ground is the ball when it is thrown? We can see that in the graph as well. It's right up there. My hand doesn't seem to stay still in this thing. There we go. Right up there. The y-intercept is what that question is asking for. If you have a good memory, you know that the equation has given us that number. It's 35 meters. But let's look at the graphing calculator for a second. If I go second function calc again, the choice that I'm looking for is number 1, value. I'm going to hit enter, and I'm going to write x equals 0. And that will tell me the y-intercept exactly. And it is 35. So it is 35 meters off the ground when it is thrown. Lastly, it asks us an appropriate domain and range for this function. We did some domain and range thinking when we were working on our windows, but the domain for this one is our time. And time is a real number, and it didn't make sense to have negative time. And we noticed that the intercept, we called it an x-intercept, but it's really a t-intercept, was 7. And it didn't make sense in the context of this question that t would be beyond that, because the ball isn't going in under the ground. So our domain would be from seconds 0 to 7. The range is the height. The height is also a real number. And it didn't make sense to have a negative height with a ball. And the maximum that height was 80 meters. So our range has constraints because it's a real-life question. I'm going to stop the video here and do the second half on another video.